Hello there, welcome to TET YouTube channel. This is the second part of our tutorial on the fan loss calculation. So by the end of this video you will learn what's going to happen to the speed, the pressure and brake horsepower of the fan whenever we increase or decrease the airflow due to being overload or not being efficient of a fan. The fan laws say that the speed versus directly to any change to CFM. Therefore, if we increase the airflow a 10%, we're gonna get 10% increase in the RPM. So in the previous video, part 1, we had to increase a 10% in the speed of the fan to find the new flow rate. So in this example, we'll increase a 10% in the airflow to find the new speed to determine the performance of the fan since a change in the airflow at new speed. So we'll use the first fan law. Fan speed new equals CFM new divided by CFM old multiplied by RPM old equals RPM new, which can allow us to change the airflow and the speed of the fan. The second fan law, static pressure new equals CFM new divided by CFM old square multiplied by static pressure old equals static pressure new, which is used to increase or decrease the pressure whenever we change the airflow or the speed of the fan. So that change is measured according to the square of the speed ratio. And the third fan law, horsepower new equals CFM new divided by CFM old cube multiplied by horsepower hold equals brake horsepower new. So we use that to increase or decrease the horsepower whenever we change the airflow or the speed of the fan, and that change is measured according to the cube of the speed ratio. So the best way to figure out what is the performance of the fan, since a change in the airflow, is looking at some examples. The question says the fan we use is delivering a flow rate of 3000 CFM at a static pressure of 0.5 inch of water column and has a brake horsepower of 0.5. If we increase the airflow 10% to 3300 CFM, what is the performance or new RPM of the fan at the new flow rate? In this case, the first fan law says fan speed new equals 3300 CFM new divided by 3000 CFM old times 1000 RPM old equals 1100 RPM new. So here, as you can see, the speed has increased from 1000 RPM to 1100 RPM. The second fan law says static pressure new equals 3300 CFM new divided by 3000 CFM old square times 0.5 static pressure old equals 0.605 inch of water column static pressure new. So the static pressure has changed from 0.5 to 0.605. And the third fan law says horsepower new equals 3300 CFM new divided by 3000 CFM old cube times 0.5 horsepower old equals 0.655 brake horsepower new. So here, as you can see, the horsepower has increased from 0.5 to 0.655. So the final condition of the new fan after 10% increase, as you can see, a 10% increase in the airflow has resulted in a 10% increase in the new fan speed, a 21% increase in static pressure new, and a 33% increase in horsepower new. So that's it for today. Thank you very much for watching this video.